Hello, Assalamu alaikum. In today's video, we'll talk about the definition of story drift and the limit of the story drift for a building structure as per the code provisions like ASCE 705 and BNBC 2020. Now, at first, let's discuss about the definition of the story drift. Here we can see that it is a frame. Now, let's just say that it's a building frame and we have applied the lateral forces F1 and F2. These forces will be determined by the ELF method, the effective lateral force method. Now we should note that from the ELF method we get the elastic level design forces, and now if these two lateral forces act on the structure will be deformed like here and there will be some displacement. Now let's say that this is first floor and this is second floor and this is ground floor. Now there will be displacement due to the lateral forces. Now here for the first floor the elastic displacement from the elastic force will be delta E1, E for the elastic force and 1 for the first floor, and for the second floor the displacement will be called delta E2. Now as per the code provision we have to convert this elastic displacement to the inelastic displacement. To do that we have to multiply our elastic displacement with displacement amplification factor CD and divide with the importance factor I. By doing this we will get the inelastic displacement delta 1. Similarly for the second floor, if we multiply the elastic displacement with CD and divide it by the importance factor I, we will get the inelastic displacement for the second floor. Now if we look at our illustration, delta 1 for the inelastic displacement of first floor and here the delta 2 which is the inelastic displacement for the second floor. Now let's have a look in the code provision. Here it's stated that the design story drift at story X shall be computed as the difference of the deflections at the center of mass at the top and bottom of the story under consideration. In this case, the considering stories are the first floor and the second floor. The story X will be the second floor. So the displacement difference between these two floors will be called the story drift for the upper story, which is the second floor. Now I think we are now clear about the definition of the story drift. Here I have included the provisions for the allowable story drift. The first reference is taken from the ASCE 705 and the second reference is taken from the BNBC 2020. You can see that these two code provisions is almost similar. As in the BNBC 2020, it's stated that the base of the code of BNBC 2020 is from the ASCE 705. And therefore the provisions for limitations is almost similar. Let's talk with the table from the reference of ASCE 705. Here you will see that the allowable story drift is based on two important elements. One is the type of the structure and the other one is the risk category. Based on these two elements, the allowable story drift is categorized. Here, for the structures other than masonry shear wall structure, you can see that for masonry shear wall there is another provision, or for 4 stories or less above the base as defined in section 11.2, and with interior wall partitions, ceilings and exterior wall systems that have been designed to accommodate the story drift. That means that the structures which are 4 stories or less, or for which the walls and partitions and ceilings that have been designed to accommodate the story drift, those structures will be fall into this category. The second category is the masonry cantilever shear wall structures, and the third category is masonry shear wall structures, and the rest of the structures will be fall under the all other structure category. And here you will see that there is another element for which the allowable story drift is categorized. For the occupancy category 1 or 2, the limit will be 0.02. For the occupancy category 3, the limit will be 0.015, and for the occupancy category 4, the limit will be 0.01. Now I will talk about the significance of these values. Here you can see there is a suffix which is HSX, and there is a note here that the HSX is the story height below level X. To understand this, let's go back to our first illustration. Here that we have found the story drift from the difference of displacement in between 2 stories. Now here you will see that the story height between these 2 stories is L2. If we divide our story drift, which is delta 2 minus delta 1 by the story height L2, we will get a value which will be called the story drift ratio. As per the code provision, occupancy category 1 or 2, the allowable story drift would be within 0.02 HSX. That means that the story drift, which is here delta 2 minus delta 1, should be less than 0.02 HSX. Here, if we shift this HSX in this side, there will be left only the value 0.02. As we have discussed earlier, this was the definition of story drift ratio. That means that the story drift ratio in between 2 adjacent stories should be within the limiting value of 0.02. Similarly, if your structure falls under the risk category 3, limiting value will be reduced to 0.015. Hope you have understand the significance of the allowable story drift mentioned in the code provisions. In the next part of this video, we'll discuss about how we can check our story drifts in the FEM software ETABS. Till then, please stay with us. Thank you.